Hello, fellow developers. Today, we're diving into a fundamental skill for any robust application, talking to files. Imagine your Python script needs to remember things or share information with other programs. That's where file input-output, or I/O, comes in. It's how your code interacts with the outside world beyond its own memory. We'll explore how to both read existing data and write new information to files, making your applications much more powerful and persistent. Think of it like giving your program a long-term memory. This capability is absolutely crucial for tasks like logging events, saving user data, or processing large datasets. Mastering file I/O allows your applications to move beyond temporary in-memory operations and truly interact with the operating system and other services. Before we start reading or writing, we need to properly open a file and tell Python what we intend to do with it. This is where file modes come in. The R mode is for reading an existing file. W is for writing new content, which will overwrite anything already there. If you want to add to a file without deleting its contents, use the A mode for appending. But opening files isn't enough. You also need to make sure they're closed properly to prevent data corruption or resource leaks. This is where the with open statement is a game changer. It's a context manager that automatically handles closing the file for you, even if errors occur. This pattern is considered best practice and is essential for robust file handling. It simplifies your code and makes it safer, ensuring resources are always released. Let's look at how to actually put data into a file. Here, we're using the with open statement with the W mode, which stands for write. Notice how mylog.txt is the file name and W specifies our intention. The asLog file part assigns the opened file object to the variable log file. Inside the with block, we use logfile.write to add strings to the file. Each write call adds its content, and we explicitly include new line characters, \n, to ensure each entry appears on a new line. Without these, all text would be on a single line. This simple pattern is incredibly powerful for generating reports, saving configuration, or creating custom log files for your applications. It's the foundation for making your programs remember information. Now that we know how to write, let's see how to read data back in. Again, we're using with open, but this time with the R mode for read. This opens the file for reading, and Python expects it to already exist. If it doesn't, you'll get an error. Inside the block, logfile.read reads the entire content of the file as a single string. If you have many lines, this can be memory-intensive for very large files. Alternatively, you can iterate directly over the log file object, which reads the file line by line, making it much more memory efficient for larger files. This method is often preferred for processing structured data where each line represents a distinct record. Understanding both read and line-by-line iteration gives you flexibility in how you consume file data. So, we've walked through the mechanics of reading and writing files, but how does this connect to building larger, more complex systems? File I/O is the backbone for many critical operations. Think about configuration files that dictate how your application behaves, or log files that record every event, crucial for debugging and monitoring. It's also how data is often exchanged between different parts of a system or even different applications. For instance, one service might write a report to a CSV file and another service picks it up for processing. Ultimately, mastering file I/O is about enabling your